Good morning, everyone. So we're going to continue learning about graphing linear inequalities. All right, so let's continue. Here we go. All right, so let's take a look at this. What happens if I just give you this graph? What equation or inequality do you think would go with that? I'm going to have you put down what you think, and you're allowed to put whatever you want, just you're not allowed to put I don't know. All right, so study that for a little bit, and that's different than the one that we did yesterday or the last class because the shading was upward. So how do you think the inequality is going to change? I'd also like you to take a look at part B as well. What if I change the inequality to be less than with no bar underneath it? So it's a strict inequality, strictly less than, not less than or equal to. What would that graph look like? Right, so you don't get to discuss with a partner or a team, but what you can do is go ahead and put some of your thoughts down, right? Again, the only thing you're not allowed to put is I don't know, and you're not allowed to skip it. Write something down. All right, so let's take a look at this. How is this graph different? Well, this graph is shaded downward. So let's go back to the meaning of what this shaded region represents. The shaded represents solutions. So these are all the solutions. So the question is, where are my solutions? The solutions are all less than this line. So all of these y values, all of my y values need to be less than or equal to my line. Well, what is the equation of that line? It's the slope is down 2 over 1, down 2 over 1, and my starting point is at 3. So that's what this translates to. All of my y values are less than or equal to this line. So this starting line, and all my y values are going to be less than that. So you can kind of think about it. I know I told you the other day I shade it going this way. That's just for a visual. But in fact, what it means is more like this. Right? So all of these y values have to be less than that line. All right, but what if I didn't put that bar underneath it? How do you think that would change? Well, notice on this one, I put the point on the line. This means I'm not going to include it, right? Remember when I did the problems I used to do an open or a solid? If it was less than, it would be an open because I don't want to include that point. So again, I'm not going to include that point. So that's going to be an open dot here, open dot here, an open dot here, and so forth. Cool? So I'm going to start at 3 and then go down 2 over 1, down 2 over 1. And this is going to be, I don't want to just draw a bunch of open lines. So what I'll do is I'll make this a dotted line. So if it's less than, I'm going to make it dotted. Right. It's still going to be the same problem where I'm going to test a point. If I test 0, is 0 less than 3? That's true. So this is the side that's shaded. Right? All my solutions are less than this dotted line. All right. So that's how you know the difference between whether to make it a dotted line or a solid line. The shading stays the same. So what I'm going to do today is I'm going to do a problem, then I'm going to have you do a problem. I'm going to do a problem, I'm going to have you do a problem because I'm going to throw in some variations of problems. All right? All right, so the first problem that I'll show you an example of is y less than or equal to 2x plus 1. Again, I'm going to start out the same way as I always do. I know that that's less than or equal to, so it's going to be a solid line. I'm going to start at 1, go up 2 over 1, and I'm just going to draw my line right there. All right? Bam. Okay, now the question is, which way do I shade? My favorite point to test is 0. So 0 gets plugged in. So 0 is less than 1. That's a question. Is 0 less than 1? Yes, it is. So that's true. So this is the side that I shade. Done. That is my solution. All right. I want you to try this one. All right, let's check your answer. Okay, it's solid. So I'm going to go down, and then I'm going to start at -1. I'm going to go up 1 over 2. Again, I'm going to just graph my line. Solid. Test the point 0, 0. Is 0 less than -1? That's false. So this is it. 0, 0 is false. So this is the side that I shade, right? Because remember, my dividing line separates the true and the false. So if I find out a point on this side is false, then everything on this side is going to be false, which means everything on this side is going to be true. All right, let's try another one. This one's going to look a little different. You have a couple of choices. You could either solve for y and then do it the way I just did it. I'm going to show you another way to look at this, just so that you have a little bit more flexibility in the way you solve problems. I'm going to make a table. And I'm going to specifically find x and y intercepts, because I could do that pretty quickly. If x were 0, this would go away. So my y value must be 2. If y were 0, this would go away. My x value has to be -1. All right, so now I can graph this. I'm going to plot my 2 points, 0, 2, and -1, 0. Now, solid, I'm just going to connect it. Bam. And then I test my point the same way I always test it. 0, 0. So -2 times 0 plus 0 greater than 2. That's my question. Is 0 greater than or equal to 2? It is not. This is false. So this side gets shaded. All right. You try this one. All right, let's check your answer. I'm going to do the same thing. If x is 0, y is -1. If y is 0, x is -1. Now I can plot those 2 points and graph my line. Remember, I only need 2 points to graph a line. So I have some strategies. I could either find 2 points and connect them to make my line, or I can use y equals mx plus b. All right, let's plug in 0, 0. We're going to test this point. So is 0 less than or equal to -1? No, it is not. That's false. So if that's false, I'm going to shade on this side. Okay, let's try another one. Got y greater than or equal to 3/2 x minus 1. Oh, not greater than or equal to, just greater than. That should be a big clue as to what's going to happen. Okay, if it's just greater than, remember we talked about that having to be dotted. The rest of it stays the same. I'm going to plot -1, go up 1, 2, 3 over 2. 1, 2, 3 over 2. This time when I make my line, I'm going to make it dotted. That's it. Still going to test a point. Still going to test 0, 0. So 0 greater than -1? Yes, it is. So this side gets shaded. All right, you try this one. All right, let's check your answer. Okay, this is dotted. I like writing it down so I don't forget. If for some reason you make it solid and you did it in pen or whatever, you can always just write the word dotted, and I'll give you full credit for that. All right, so start at 2, go down 1 over 4, down 1 over 4. And this is my dotted line here. I'm going to test 0, 0. So is 0 greater than 2? Right, that's the point I tested. Is 0 greater than 2? That's false. So this is the side I'm going to shade. All right. All right. Last one. Let's try this one. Another one that's in that form. So again, I'm going to use this idea of finding x and y intercepts. So if x is 0, y has to be -3. And all I did was divide this by -3. Sorry. I divided both sides by -2. So y equals -3. And then if y were 0, it says it right there, x is 6. So when I graph this, 0, -3, and 1, 2, 3, 4, 5, 6. And because this is a strict less than, this is going to be dotted. All right, I'm going to test 0, 0. So 0 minus that, less than 6. Is 0 less than 6? Yes, it is. That's true. So I'm going to shade up. Right. Go ahead and try this one. All right, let's check your answer. I'm going to plug in 0 for x, which leaves -3 on this side. Plug 0 for y, which leaves 2 for x. So 0, -3, and 2, 0. Again, dotted. I'm going to test 0, 0. 0 is lovely because some of you are starting to do this in your head where you can just say, hey, that all disappears. So is 0 less than 6? That is true. So I'm going to shade up here. All right. So hopefully that gave you a little bit of practice, a bunch of problems to look at definitely. So if you have any questions, please ask.